Hello, this is Alex Eames from RasPiO.tv. Okay, so you've put your RasPiO Duino together, you've done the setup and installed the Arduino IDE, and you've gone through the blink sketch and you've tested all the ports with the LED, each of the ports in turn. The next thing we need to do is to install the rest of the sketches, unless you want to pull them in one by one. It's much easier to install them all at once the Arduino IDE is already installed. As you do this, either in a LXDE window or in the command line, you type the following command: curl space rasp.io /duino.sh space pipe space bash, and then press enter. What that will do is it will clone the RasPiO Duino GitHub repository and put all of the files in the right place. There you go, it doesn't take very long. You see that part's done already. Then if we have a quick look, you should see here there's a directory called RasPiO Duino, and here there's one called Sketchbook, which will have the right files already copied into it. And you should also see here is Duino test serial Python script, which is something that we will need right at the end when we get to the very last sketch. And once we've got that done, it's time to make a flip-flop. So what's a flip-flop? A flip-flop is a circuit where you've got two lights or LEDs and one comes on when the other goes off, and vice versa, and they keep alternating. So what we need to do is, we've already got one LED on the board. What we're going to do is we're going to wire up another one, and we're going to wire that up to a separate port, and we're going to have them switch alternately. So what we need to do is we're going to take the LED, and you'll see one leg is longer than the other. The long leg is the positive. We want to take one of the 330 ohm resistors, and we're going to join that to the long leg simply by wrapping it round. About 3 or 4 times is enough, and that gives you a connection. So we've wrapped that round, and we're going to put the end of the resistor into pin 5, which is over here. So we'll put that in, oops, nearly missed. Put that in pin 5, and the other end goes to ground, which is this rail. I'll point with this rail here, and we've got 2 sockets we can use for that here. So the negative end of the LED goes into ground. Now the other way of telling which is positive and which is negative on an LED, if I can get it into focus, here we go, is that's the shorter leg, but that side also has a flat on it, whereas the other side is rounded. So that's what it looks like. One end pin 5 through the resistor, through the long leg of the LED, and the other leg goes to the ground connection. So then what we're going to need to do is load up our sketch. Well, now we've installed the rest of the sketches, let's have a look and see if they're there. So we'll click on File, Sketchbook, and here you go. You can see most of these are sketches that we've installed from the repo. A few of them at the bottom are ones I already had. So now let's load up the flip-flop sketch and take a look at it. So File, Sketchbook, flip-flop. So what's altered? Well, we've changed the comment at the top from the previous sketch. Not a very big change there. These lines are new. We've added another LED variable, and we've added a time delay variable as well, which we're going to use down here in our main loop a couple of times. What that means is that instead of hard coding the time delay, we can set it once at the top and it's the same throughout. This is quite a useful feature. So line 16, which is this one here, we've added our second output, which was the pin 5 new LED, we're setting that up as an output in our setup function, and we've also added this line and this line here to put our second LED in. And as you'll notice, I mentioned earlier already, the time delay is now variable rather than being hard coded. So we've got one going high when the other goes low, going low when the other goes high, which is why it alternates between one LED on and the other one on, and vice versa. So there you go, there's a quick walkthrough of the flip-flop sketch as it is now. Okay, so let's upload that using the programmer. File, upload using programmer, or Control-Shift-U. And we'll see that it compiles first, and now it's uploading. Now it's done uploading, and you can see it's flashing as it ought to be. You might find that you get full brightness on the onboard LED if you remove the SCLK jumper, which is the middle one. See, on this particular one, on an A+, for example, I've never actually seen this before, but I can hardly see the LED lit at all. But if I pull the SCLK jumper, it's working just as it should. I've not seen that on a Pi 2 or a B+ before. I'm not quite sure why that happens, but it must be something to do with the bug that I mentioned in the earlier setup video. It is actually possible to make a flip-flop using just one pin. The built-in LED is on pin 13, so if we connect the other LED backwards to pin 13, we could get a flip-flop using just one pin. So when the pin is high, one LED is lit, and when the pin is low, the other LED is lit. So let's just quickly show you how to do that. Basically, we hook it up backwards so that this one goes to pin 13 and the other end goes to positive. And that's covered on page 18 of the manual. So when pin 13 is low, this LED is lit, and when pin 13 is high, this LED is lit. That doesn't require any changes to the program, but you could eliminate the lines that deal with pin 5 completely to simplify your code. So now I'm going to put that back how it was. I'm going to that to ground and that to pin 5. Okay, so now I've swapped over to a Pi 2 with slightly more up-to-date Raspbian on it, and the reason I've done that is so I can avoid having to keep removing the SCLK jumper. As you can see, it's working perfectly well with both LEDs with that jumper in place. So now we're going to expand on what we've already done, and we are going to use pin 8, which is this one here, as an input to determine the speed of the flip-flop. So what we're going to do is we're going to take one of our 330 ohm resistors and we're going to connect it between pin 8 and we'll say 3V3 to start with, so that would make pin 8 high. And if we swapped it, you can see that's in the 3V3 socket there. The one next to it's ground. If we wanted to swap it and make pin 8 low, we would put it in that one there to ground. You can also use the holes as long as it's got a contact. So let's load up the sketch. The sketch is called flip-flop with input. So to upload our flip-flop with input sketch, we go File, Sketchbook, flip-flop with input, and then click that. Then this will load. I've already loaded it. So what's new in this sketch? The first new line we have is this one here, which is defining a new variable for the value of our input. Okay, then a little bit further down we are setting up pin 8 as an input, and then down here in the main loop this code is new. So we have the input value, which is the variable we defined up here, is the value of reading pin 8. So that's going to be 1 if it's connected to 3v3 and 0 if it's connected to ground. So then we've got a little bit of logic here that says if the input value is equal to 1, the time delay will be 500 milliseconds. So if pin 8 is connected to 3v3, we get a 500 millisecond time delay. Otherwise, the time delay will be 1000, so it'll be slower. 500 is what it was before, and 1000 is slower. So that means if pin 8 is not connected to 3v3, i.e. it's connected to ground, the time delay will be slow. And then the rest of the sketch is the same as it was before. But you see now why we made the time delay a variable, because that gives us a chance now to be able to play with it. So let's upload that sketch. So File, Upload using Programmer, or Control-Shift-U. First it will compile. As you can see, there's a progress indicator here. And now it's uploading, and now it's done. Okay, it doesn't look like anything's changed, and that's because we've set our input to high, so it's still flashing at the same speed. The time delay is still as it was, but if we change that to ground, it's flashing slower now. Can you see that? So when input 8 is high, as in connected to 3v3, which it isn't at the moment, the time delay is 500 milliseconds. I'll show you that by changing it. Okay. And when input 8 is connected to ground, is low, the time delay is 1000 milliseconds, which is a whole second. So that's slower. You see, you can play with that to satisfy yourself that that's how it works. Now we've done that, let's add 2 more resistors to 2 more of the pins and use them as input. We're going to have a resistor on pin 6, pin 7, pin 8, which connects either to 3v3 or ground, and we will vary the switching speed accordingly. So let's just set that up. I think I'm going to bend this LED out of the way so that we can see better. Right, so that's pin 6. No, that's pin 6 to 3v3. Now pin 7 to 3v3. And now pin 8 to 3v3. I'm going to stick it in one of these holes on the 3v3 rail. Can you see that I've done that? As long as it's touching, there'll be a connection. Okay. So make sure that none of your wires are actually touching each other here. Otherwise they can make things go not the way we're expecting. So right now we need to upload a new sketch. So now we want to open the flip-flop with 3 inputs sketch. So we'll go File, Sketchbook, flip-flop with 3 inputs. And here's our new sketch opened. The first part of the sketch is the same as before. The first new bit is the extra pins we've added as inputs that we've set up in the setup function. Our main loop is slightly changed. It starts off by setting the time delay to 1000 milliseconds. Then it reads pin 8. Okay? If the pin 8 is high, it divides the time delay by 2. Then it goes on to read pin 7. If pin 7 is 1, i.e. is it connected to 3v3, it divides the time delay figure by 2 again. And we get the same thing repeated for pin 6. It reads pin 6. If pin 6 is connected to 3v3, halve the time delay. So for each pin that is connected to 3v3, the time delay is halved. So if all 3 pins are high, then the time delay is going to be 1/8 of what it was to start with, and it was 1000 to start with. If 2 pins are high, it's going to be 1/4. If 1 pin's high, it's going to be 1/2. And the last part is the same as we had before, just switching the LEDs on and off. So let's upload that sketch file, upload using programmer, compiling, uploading, done. Now you can see, look, all 3 of the input pins, 6, 7 and 8, are connected to 3v3 at the moment. So what that does is for each of those pins which is connected to 3v3, it halves the delay time. Okay, so if I pull one of those out and put it in ground, it should double the delay time. Okay, if I do another one, that should slow things down even more. And if I do the last one, that should make things even slower. So let's change one of them back again. That should speed things up. Change another one back. That should speed things up even more. And the last one should make things stupidly fast. So what we have here is we've got 3 input pins which are being read and used to determine the time delay. We're coming to the end of this video now. You've learnt about how to do various flip-flop related exercises on the RasPiO Duino, and also how to install all the rest of the sketches. To go a bit further in this, I recommend you have a look at page 24 onwards of the user guide, where it covers 3 different aspects which I haven't covered in the video. So the first one on page 24 is actually how to incorporate loops into the code and get rid of repeated code. That's a really useful technique, and I recommend you have a look at that on pages 24 and 25. Then on 26 and 27 we are introducing Boolean operators, or and not, which is a really good way of being able to make logic decisions. And these are all using the same circuit, the same flip-flop circuit. And the last part is how to eliminate floating signals, which is an interesting thing. You might notice sometimes you get erratic signals, and this shows you how to use pull-up resistors in the Atmega chip. So I commend those bits to you, and the next video we'll have a look at some PWM experiments. So until next time, goodbye. This was Alex Eames for RasPi.tv. Thank you for watching.